Hello everyone, my name is Joshua Cooley and I'll be walking you through the LunaComp 3 NASA Lunabotics Expo poster. To start off, here is our rover overview and the components that we have implemented. At the top, you see the drum nozzle, a RealSense camera, an energy meter, a power panel, a conveyor belt, conveyor walls, POSIX tags, and a linear actuator. So the rover was broken down into 4 different subsystems to help plan and manage the overall project. The NASA Robotics Competition is a university-level competition in which students must build a prototype rover to operate in a lunar-like arena. The team designed our rover around NASA constraints with all of our rover specs within the allotted dimensions. Our design process was developed around the competition schedule, and we chose the V model. So the team was able to test and implement autonomous operations of localization, mining, digging, and depositing. Here we used encoders to control all of our components, such as the winch, inner drum, and outer drum. The Intel RealSense camera was tested and used, creating an array of values that determine the distance from the objects. Trilateration algorithms were created and used to localize the rover within respect to the arena, and this helped in navigation. As previously mentioned, the power distribution panel supplied 12 volts of power to various components in our design. The team also completely stripped the rover of previous electrical components and rewired it. The drum nozzle was 3D printed and tested to control the flow of regolith out of the drum. The conveyor belt was hand-built using internal rollers, a CNC frame and hinge, and 3D printed sidewalls. This unique design collapsed and was created to stay within our dimension requirements while not deployed. When deployed, the system was well over the requirements for deposition that we needed. For the conveyor belt, rocks kept getting lodged in between the frame and the rollers, which caused jams. A roller was then made to mitigate this issue, as you can see here. For our digging buckets, the team had many issues with rock jams and rocks getting stuck in between the 2 drums. So we made relief cuts and we had an additional rubber backing for the buckets. The power distribution panel supplied 12 volts of power to the devices. However, there was some loss while operating. The team implemented buck converters to supply a continuous output voltage for these devices. To help mitigate some issues with rock jams and encoder count issues, the team implemented various redundancies to control the systems for damage.